Have you ever noticed, like, when a chatbot or an AI tool you use every single day suddenly gets, I don't know, just weird?
Oh, yeah. Like the uncanny valley effect.
Right, exactly. You're typing your usual prompts, your workflow is exactly the same, and the app isn't actually broken.
Yeah, there's no glaring 404 error.
Right, no spinning wheel of death, the screen isn't freezing, but the vibe is just completely off.
It's a very specific feeling.
It really is. The answers are technically correct, but it feels like you're talking to a slightly lobotomized version of the entity you were interacting with yesterday.
Yeah, it's deeply unsettling
Yeah.
because you realize the system is technically functioning,
Right.
right? The servers are up, the code is compiling, but the personality or the nuance, it just feels hollowed out.
Yeah, you feel like you're losing your mind a little bit because you can't point to a specific bug, but you know the soul of the machine is fading. Well, welcome to today's deep dive. Our mission today is to unpack exactly how software engineers keep AI models from losing their souls through these incredibly clever, completely invisible deployment strategies.
And we have a fantastic piece of source material guiding us today.
You really do.
We're looking at a highly imaginative piece by Aaron Rose. It's called The Secret Life of Azure Canary Deployments for LLMs,
Such a great title.
right? And it was published on tech-reader.blog.
Mm-hmm.
And what makes this article stand out is that Rose entirely bypasses the dry, impenetrable technical manual approach.
Thank goodness.
Yeah, he takes these incredibly dense software engineering architectures and translates them into a fictional narrative.
Yeah, so he invites us to step into this grand Victorian library in London. And it's the kind of place where code quality isn't just a metric, it's absolute craftsmanship.
Which is such a great setting for this.
It is. And in this library, we meet Margaret. She's a seasoned, totally battle-tested senior software engineer, and she has this junior colleague, Timothy. And through their eyes, we are going to learn how the industry actually keeps an AI's vibe in check.
So the scene opens with the library operating at peak capacity. Everything has been running smoothly for weeks. The scarlet guardrails, which represent their hard-coded safety checks, are entirely silent.
No alarms going off.
Exactly. The engineering team recently pushed a major model update, and it sailed through every single standard unit test they threw at it.
Green lights across the board. But Timothy, the junior dev, he notices a creeping problem.
Yeah, he's paying attention.
He is. The readers in the library are starting to complain.
Mhm.
And they aren't complaining about broken links or missing books. They are saying the library's soul feels different.
Wow.
Yeah. The AI's responses are accurate, but they've become noticeably shorter. They're more clinical, lacking that usual warm librarian tone that the users have come to love and trust.
And from an engineering perspective, I mean, this is the most frustrating scenario imaginable. Timothy points out to Margaret that nothing is actually broken on the dashboard, yet something vital is definitely fading away.
Right. Okay, let's unpack this for a second, because we see this happen in the physical world all the time.
Oh, totally.
Think about a favorite local restaurant you've been going to for years.
Yeah.
The food isn't burning. The kitchen is still passing all its local health inspections with flying colors.
Right, the chicken is cooked to the mathematically correct internal temperature.
Exactly. But the chef has clearly lost their passion. The food just doesn't taste the same. The menu has suffered a complete vibe shift.
That restaurant analogy translates perfectly to the software realm.
Mm-hmm.
Because a health inspection, just like a standard unit test in code, is strictly binary.
Right. It's a yes or no.
Exactly. It asks, did the server crash? Did the function return a fatal error code? And Margaret introduces the technical term for this loss of passion in generative AI.
Mm-hmm.
She calls it semantic drift.
Semantic drift.
Yeah, and semantic drift is incredibly insidious. Traditional logic tests are built exclusively to catch hard crashes. They are fundamentally incapable of detecting qualitative decay in a non-deterministic system, like a large language model. Margaret delivers this striking warning to Timothy in the story. She describes semantic drift as a slow gas leak that doesn't trigger the fire alarm.
Oh, wow. That is a terrifying visual.
It really is.
Because a fire alarm is built with sensors specifically looking for heat and smoke. It is completely blind to an invisible, odorless gas that is slowly suffocating everyone in the building.
Exactly. If your testing apparatus only looks for smoke, meaning syntax errors, latency spikes, or complete outages, it will completely ignore the fact that the actual quality of the output, the soul of the application, is degrading minute by minute.
The AI is still talking, but it's lost its personality.
Right.
So if the fire alarm is blind to the gas leak, how do you actually protect the library? I mean, Margaret doesn't panic in the story.
No, she's a pro.
Yeah. She picks up this sharp cobalt blue marker and she draws a small bird cage right at the entrance of the library.
Which is such a cool visual. She tells Timothy that to protect the library's standards from semantic drift, they need to abandon what she calls hopeful deployment.
Hopeful deployment, just crossing your fingers and hoping it works.
Pretty much. Instead, they must move to a rigorous strategy known as traffic shifting validation. She calls it the canary.
Okay, here's where it gets really interesting because Timothy asks the exact question that's jumping into my mind.
Which is?
He asks Margaret, how do we test a soul? And why the bird cage? Like, are we talking about a literal canary in a coal mine situation here?
Yeah, the historical metaphor maps directly to the modern engineering practice.
Okay.
In the early days of coal mining, miners would actually carry a caged canary down into the tunnels.
Right.
Because canaries have a much higher respiratory rate and lower tolerance for toxic gases like carbon monoxide than humans do.
Right. So if the canary stopped singing or, passed out on the floor of the cage, the miners knew they had a very narrow window to evacuate before they even felt the effects of the invisible gas themselves.
Exactly. And in software engineering, a canary deployment works on that identical principle of an early warning system.
Okay. How so?
Well, rather than launching a brand new, unproven version of the AI model to every single user all at once, which is the hopeful deployment, Margaret warned about engineers use the load balancer to act as a cobalt shield.
Oh, I see.
They dynamically route a tiny fraction of the library's traffic to the new model.
So they basically slice off a tiny segment of the audience to act as the test subject.
Exactly. In Margaret's architecture, she isolates just 5% of the traffic. Those 5% of users are the canaries.
Got it.
The system monitors these specific interactions. If this newly deployed version of the AI begins behaving oddly, if it starts exhibiting that clinical soulless semantic drift, the system severs the connection to the new model.
They just pulled the plug on the 5%.
Instantly.
Yeah.
The brilliance of this traffic shifting strategy is limiting the blast radius. The other 95% of the users in the library are completely shielded from the experiment. They're still talking to the older, stable model. They never even realize an update was attempted and rolled back.
Right, so you don't test a radical new recipe on the entire Friday night dinner rush.
Exactly.
You send it to one table and watch to see if they send it back to the kitchen.
Perfect analogy.
But Timothy, our ever-curious junior dev, he points out a massive logistical hurdle here.
Yeah, he does.
He asks Margaret how a computer algorithm actually measures oddly if the answer the AI gives is technically factual.
Right.
Like, if the user asks for the capital of France, and the old, warm AI said, the beautiful city of Paris, and the new clinical AI just says Paris.
Yeah.
The factual payload is identical. How does the machine know the vibe is off?
That is the million-dollar question.
Yeah.
And Margaret solves this fundamentally qualitative problem by introducing a highly quantitative tool. She draws a small vault on her whiteboard and introduces the concept of a gold standard archive.
A gold standard archive. Okay, let's unpack how that actually functions.
Think of it as a meticulously curated baseline. The vault contains a massive data set of the absolute highest quality historical interactions the library has ever produced.
Oh, cool.
It's essentially the AI's greatest hits compilation. When the older AI was acting perfectly, hitting the exact right notes of warmth, accuracy, and tone, the engineers froze those specific prompts and responses and stored them in the vault.
So they have a frozen snapshot of what perfection looks like.
Exactly. And they use that snapshot for mathematical similarity comparison. When the new 5% canary model generates an output, the system compares it against the gold standard.
Okay.
It doesn't just look at the raw words. It turns the text into mathematical coordinates and calculates the distance between the new response and the perfect historical response.
Wait, hold on.
Yeah.
If we are constantly hitting this massive vault of data and mathematically scoring every single new answer against the archive, wouldn't that create a catastrophic bottleneck?
That's a very valid concern.
I mean, think about the user waiting for their answer. Does the system have to pause, query the vault, run a complex vector math comparison, decide if the vibe is acceptable, and then finally render the text on the user's screen?
Right.
Because that sounds like it would introduce massive latency.
Oh, if the architecture were designed that way, it would absolutely ruin the user experience. You'd be adding seconds of delay to every single chat message.
Which feels like an eternity online.
Exactly. But this is where Margaret's engineering prowess really shines. She mitigates the latency problem through two specific mechanisms. First, they don't measure every single breath the system takes. They sample.
Ah, okay. So they aren't scrutinizing every single query from that 5% slice.
Right. They only grab a statistically significant representative sample of the canary traffic. And crucially, they process this similarity scoring asynchronously.
Now, asynchronous processing is one of those terms thrown around constantly in tech, but it's vital to understand here.
It really is. It means they have completely decoupled the scoring process from the user's critical request path.
Okay, so what does that look like in practice?
In practice, the user asks his question, the Canary AI generates the response, and that response is instantly blasted back to the user. There is zero delay.
Wow, okay.
The user gets their answer immediately. But a split second after that interaction is finished, a background worker process grabs a copy of that response and runs it against the gold standard archive.
I love that.
Right.
The quality control happens entirely behind the scenes after the facts.
Exactly. The user is never held hostage waiting for a similarity score to compute. The system calculates the mathematical distance a second or two later.
Right.
And if it starts noticing an aggregated trend, if the mathematical distance between the canary's outputs and the gold standard starts growing wider over several consecutive samples, that is the definitive signal that the vibe is shifting. The semantic drift is real.
So to use Margaret's metaphor, the system detects that the mathematical bird has stopped singing.
Beautifully put. The early warning system triggers an alert without ever having interrupted the speed or flow of the library itself.
It's like having a Michelin food critic standing by the kitchen doors, right?
Yeah.
Secretly tasting a tiny spoonful of the dishes as the waiters carry them out. The critic is scoring the food, but the customer at the table doesn't have to wait for the critic to finish their review before they are allowed to take a bite.
That's spot on.
It's invisible, continuous quality control.
It really is an incredibly elegant solution to measuring non-deterministic outputs.
Okay, so the 5% canary test is running smoothly. The asynchronous background workers are sampling the traffic, comparing it against the gold standard archive, and the mathematical distance is incredibly tight.
The bird is singing beautifully.
The bird is singing. The AI sounds warm and helpful, but a test can't run forever. At some point, an engineer has to make the terrifying decision to push that code to the rest of the users. How do they decide when it's actually safe?
Margaret illustrates this next concept by drawing a timer on her whiteboard. She introduces the graduation threshold.
The graduation threshold.
Yeah, you don't just leave a model at 5% indefinitely.
Yeah.
And you certainly don't rely on a gut feeling to decide when to scale it up. You establish hard, predefined metrics before the deployment even begins.
Right. You need a mathematical burden of proof to earn trust.
Exactly. For their specific library architecture, Margaret states the absolute requirement is exactly 24 hours of uptime and 10,000 successful drift-free requests.
Wow.
That is the concrete hurdle the Canary must clear to prove its stability.
It really reminds me of giving a teenager a learner's permit for driving.
Oh, yeah.
You don't just hand over the keys to the Ferrari on day one because they successfully backed out of the driveway once.
Okay.
You say, you can drive to the grocery store and back in broad daylight with me in the passenger seat. And they have to execute that mundane task flawlessly over and over again to prove they won't hit a curb.
And if the teenager or the Canary stays in the green for that required time and volume, you still don't hand over the Ferrari immediately. You shift the traffic incrementally. Margaret explains that once the Canary clears the 24-hour and 10,000 request threshold, the load balancer shifts the traffic from 5% up to 25%.
So they widen the blast radius slightly.
Exactly. They watch the similarity scores at 25% volume. If the metrics hold steady, they push it to 50% and finally to 100%.
Nice.
The entire philosophy is rooted in trust, but verify. Then trust a little more and verify again.
It's a beautifully methodical progression. But Timothy is an anxious junior developer, and honestly, I deeply relate to his anxiety in this scene.
Me too.
Because he poses the ultimate nightmare scenario. He says, imagine we are running the 5% Canary. We spot semantic drift. The background workers alert us that the vibe is off, the bird has stopped singing, and the system needs to instantly roll back to the old model.
Right.
What happens if the rollback mechanism itself fails? What if the cobalt lever on the dashboard jams?
It is the exact scenario that keeps reliability engineers awake at night. The safety net you built to catch the failure ends up failing itself.
Because in complex tech stacks, redundancies and fallback systems fail all the time.
All the time.
If the automated rollback breaks, do those 5% of users just get permanently stuck talking to the clinical soulless AI? Is the library just ruined for that slice of the audience?
This is where Margaret's teachings transition from pure architecture into the deep philosophy of reliability engineering.
Okay.
She anticipates Timothy's fear. She draws a second, much heavier, distinct lever on the whiteboard. She labels it the emergency brake.
Ah, a manual override system.
Exactly. It is a heavy-duty, fail-safe circuit breaker. If the automated rollback fails, if the servers cannot smoothly transition the traffic back to the old, warm AI model, this emergency brake kicks in and severs the connection to the generative model entirely.
Wow.
It forces a completely safe, static response.
The static response, so it stops generating text altogether.
Yeah. The system halts all AI generation for those affected users and outputs a fixed, hard-coded message. The library is temporarily experiencing high volume.
They just shut the AI down entirely for that 5% and give them a generic error message in disguise.
Basically.
Honestly, that feels like a drastic measure. Isn't displaying a fake high-volume message terrible for the user experience? You're actively denying them service.
It is drastic, and Margaret readily admits to Timothy that is not the ideal outcome. But her justification highlights her core engineering philosophy. She tells Timothy, the worst outage is the one where the system lies about being fine.
The worst outage is the one where the system lies about being fine. That is profound.
Isn't it? In the Cobalt arc, which is their internal framework for managing the library, Margaret explains that they fundamentally favor displaying a quiet, closed sign over displaying a broken, open sign.
I really want to frame that concept because it applies so universally outside of software. Like, if I walk up to a local coffee shop and there's a sign on the door that says closed for maintenance, I might be mildly annoyed that I can't get my caffeine fix.
Sure.
But I walk away and come back the next day. My fundamental trust in the business isn't broken. But if the neon sign says open and I walk inside and the espresso machine is actively on fire, or the barista is staring blankly at the wall acting like everything is completely normal, I am never stepping foot in that coffee shop again.
Exactly. If an LLM is providing clinical, soulless, or even subtly hallucinated answers, but presenting them with total unwavering confidence, it rapidly erodes the user's trust in the entire ecosystem.
Right.
That static, we're experiencing high volume right now, message acts as a shield. It preserves the integrity of the system and protects the gold standard.
It protects the soul of the library, even if it requires denying service for a few minutes to protect the long-term relationship with the reader. That philosophy brings us to the resolution of Aaron Rose's story. Timothy and Margaret are sitting at their desks, watching the live dashboard. A new update actually rolls out into the production environment.
The 5% Canary slice goes live.
Right. And a few minutes into the deployment, the tension on the dashboard spikes. The similarity score, driven by that asynchronous background check against the gold standard archive, starts dipping sharply into the red.
Oh.
The mathematical distance between the new model's output and the historical baseline is growing rapidly. The new AI is drifting.
But the true beauty of Margaret's architecture is what happens next. Before Timothy can even reach for his mouse in a blind panic to manually intervene, the Cobalt lever flickers on the dashboard.
Amazing.
The background workers detect the gas leak, the mathematical canary stops singing, and the automated rollback triggers flawlessly.
The load balancer shifts the traffic back to the previous, stable version in a matter of milliseconds. The warm, nuanced librarian's voice remains perfectly intact for the public. Timothy watches the chart stabilize, exhales deeply, and realizes the most important part of the entire ordeal the readers didn't even notice.
Which is the absolute highest compliment a deployment architecture can receive.
Truly.
Margaret caps her Cobalt marker and delivers her final piece of wisdom to her junior colleague. She tells him, reliability isn't about never making a mistake. It's about ensuring your mistakes stay small, quiet, and far away from the front desk.
Small, quiet, and far away from the front desk. What an absolute masterclass in system design.
It really is.
So for you listening, the next time you open your favorite application and the interface updates seamlessly, or you're relying on a chatbot and its tone remains consistently helpful and nuanced day after day, week after week, you'll know what's actually happening.
Yeah, you'll know about the invisible 5% canary singing or quietly passing out behind the scenes.
Exactly. You'll understand the immense computational effort of the gold standard archives silently scoring the vibes via vector distance, and the heavy emergency brakes standing by, ready to pull a quiet, closed sign if the system ever tries to lie about being fine.
Once you understand the mechanics of traffic shifting validation, it completely changes how you view the stability of the digital tools we rely on. You realize it's not magic, it's just meticulous, invisible craftsmanship.
It really is. Now, to wrap up today's deep dive, I want to leave you with a thought that takes Margaret's brilliant engineering architecture and applies it far outside the bounds of a Victorian library or a server farm.
Okay, let's hear it.
Think about this. If software engineers can build tools to asynchronously sample data, map it against a curated gold standard archive, and mathematically measure the semantic drift and the vibe shift of an artificial intelligence, could we eventually use similar background frameworks to measure the qualitative drift in our own human environments?
Oh, wow.
Right. Imagine a tool that runs asynchronously in the background of your work life. A tool that gently aloots you if the tone of your own emails or the collective tone of your company's internal communication is slowly suffering a gas leak of empathy over time.
That is fascinating.
If your own human similarity score started drifting too far from your personal gold standard of kindness or patience, would you want an early warning system to tell you before your coworkers felt the vibe shift? It's something to ponder. Until next time, keep an eye out for those canaries.